we are going to deal with some problem sums in the field of combination. These problem sums involve the concepts of combination. So here goes the first question. If NC8 is equal to, actually it should be read as CN8. Similarly, find NC2. So coming to the solution part, here I shall provide a side note. Actually the main part only I would prefer to write it down. We know that this is important concept. We know that if this is the expression we are having with us, this will imply what? Either A is equal to B and it should be or. Either A is equal to B or N is equal to A plus B. So let us mark this as 1 and this as 2. Given in this question, what do we have? Given NC8 is equal to NC2, where 1 is not applicable. Where 1 is not applicable. Therefore 2 implies why 1 is not applicable, because these parts, you please observe, A is equal to B. Is 8 equal to 2? No, not possible. Therefore only this expression will be applicable here. So ultimately N will be equal to 8 plus 2, that is equal to 10. So in our question, what do we have to do? We have to find out NC2. So let us find out. Already this value 10 for N we already got. Therefore NC2 is equal to 10C2, which can be written in the form, using formula for combination, can be written like this: 10 minus 2. So I get here factorial 10 divided by factorial 2 into factorial 8. Now breaking 8, 10 into 9 into factorial 8 divided by 2 into factorial 8. These two got cancelled, so I get here 5 after cancellation, and the result comes as 45. Now coming to the next question. First one, determine small letter n if twice NC3 is to NC3 is equal to 12 is to 1. 12 is to 1. So coming to the solution part, what do we have? Here twice NC3 is to NC3 is equal to 12 is to 1. So in the numerator part there will be twice NC3. In the denominator it will be NC3 12 by 1. Then after, what do we get? In the numerator part I shall be getting factorial twice n divided by factorial 3 into factorial twice n minus 3. The whole thing is divided by, let us break the lower part now, n factorial divided by 3 factorial, then it will be n minus 3 factorial n minus 3. Let us write it properly. It should be n minus 3. At the same time, this will be equal to 12. Now, arranging the terms properly, what do I get? See, this factorial 3 already got cancelled. Then in this part, in the first part, I am talking about this part. In this part, I can break the terms like this: twice n, then twice n minus 1, twice n minus 2, then factorial twice n minus 3. Whole thing is divided by factorial twice n minus 3 into this denominator will come up now. That means I shall be having here factorial n minus 3, while this n factorial n can be broken to the form n into n minus 1 into n minus 2 into factorial n minus 3, that is equal to 12. Now this is the way we can make cancellation. This is the way cancellation can be done. Then n got cancelled. Let us check what is left now. So in my hand I have 2 into this. From this part I am taking out 2. So what are the things left? Twice n minus 1. After taking common 2 from this part, what will be there? N minus 1. While the denominator will be n minus 1 into n minus 2 is equal to 12. So n minus 1 got cancelled. After that, what do I get? It is 4. Twice n minus 1 is equal to 12 n minus 2. So by 4 this can be cut and result will be 3. So I get twice n minus 1 is equal to thrice n minus 6. So it will be twice n minus thrice n is equal to minus 6 plus 1. So result will be ultimately minus n is equal to minus 5. Minus minus got cancelled. I get here n is equal to 5. So this is the answer. A similar type of question under the same question. The second question is of this kind. Twice n C3 is to NC3 is equal to 11 is to 1. So in the same way as we did the previous sum, we can do this one. So I think you can try yourself. So this one, please try yourself. Now let us come to the next question. Here goes question number the next question. So what is given here? How many chords? How many chords can be drawn through 21 points on a circle. So let us come to the solution part. Suppose this is a circle. This is the center. I want to draw a chord here. So a chord involves how many points lying on the circle? Very clearly, this is point number 1 and this is point number 2. So each chord will involve 2 points. So for drawing each chord, 2 points will be required. So here I get total number of points on the circle. Total number of points on the circle is equal to 21. After that, we shall write number of points involved in each chord equals to 2, of course, because these are the 2 points involved. So in every case this will be applicable. Therefore, means each time out of 21 points we have to select 2 points for drawing chord. Therefore, number of possible ways of drawing chord will be equal to 21C2. So this can actually, there was a formula NCR is equal to NCN minus R. So let's use this form this time. Let us check what we get. It will be 21C 21 minus 2. This is the form I am applying here. So I get 21C 19. So let us break it now. 21 factorial divided by 19 factorial, then factorial 21 minus 19. Directly also we can do, thing is same. So I get here 21 into 20 into factorial 19 divided by factorial 19 into factorial 2. These two got cancelled. So 21 into 20 by 2. After cancellation, I get back 210. So this is the answer for this part. Then after, coming to the next question. So here in this case, in how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 number of girls. So coming to the solution part, what can we write? Given total number of boys, given total number of boys is equal to 5. So number of boys to be selected at a time is given to be 3. Number of boys to be selected is equal to 3. Therefore, possible number of ways of selecting boys will be what? Total 5 number of boys were there, out of which exactly 3 boys we have to select. So 5C3 out of 5, I am selecting 3 boys. At the same time, and is given, so of course whatever result we are going to get next should be multiplied with this possible number of ways of selecting boys. So again what do we have? Total number of girls, total number of girls is equal to, how many do we have? 4 girls. So number of girls to be selected is how many? 3 girls are to be selected. So I shall be writing 3 here. Then possible number of ways of selecting girls this time. Possible number of ways of selecting girls will be how many? Of course, from total of 4, I am selecting 3. So after this, what do I have to write? Total number of selection of total number of possible ways of selection of boys and girls. So where there is and, there is into. So we shall write here total number of possible ways, total number of possible ways equals to 5C3 into 4C3. So what we shall get here after reduction, 5 factorial divided by 3 factorial, then 2 factorial into 4 factorial. This is all, actually combination formula I am applying here. Then 3 factorial, then it is 1 factorial. So after breaking it, 5 into 4 into 3 factorial, then after I can write here 3 factorial, then into 2 into 4 into factorial 3 divided by factorial 3. These two got cancelled, these two again got cancelled. So the result will be, here it is 40, hence is the answer. Then after another question, another important question, problem sum. So here I get, next question is question number 5. Find the number of selecting, find the number of ways of selecting. Find the number of ways of selecting 9 balls from 6 red balls, then 5 white balls, then after 5 and 5 blue balls, 5 blue balls. If each selection consists of consist of 3 balls of each color. 3 balls of each color. So here in this case, what do I get? Total number of ways of selecting 9 balls from 6 red balls. Actually in total 9 balls we have to select from 6, total of 6 red balls, then 5 white balls, then 5 blue balls. Each selection consists of 3 balls of each color, means actually we have to choose 3 red balls, exactly 3 red balls, then 3 white balls, then after 3 blue balls. So 3 plus 3 plus 3, total of 9 balls are to be selected. So first of all, I'm going to write what are the informations provided in the question. So let us write down. Given number of red balls, is equal to 6, then number of white balls is equal to 5, then number of blue balls is equal to 5. So here in this case I have to mention this thing, that according to question, each selection consists of 3 balls of each color. 3 balls of each color. Therefore, possible number of ways equals to, I have to write here, out of 6 balls I am choosing 3, and where there is and, there is into. Out of 5 white balls I am taking 3 balls, and where there is and, again into, I have to choose 3 balls, 3 blue balls out of total of 5. So let us break it. After simplification, what result we should get? Let us check. Factorial 6 by factorial 3 into factorial 3, here in this case factorial 5, then after factorial 3 into factorial 2 into again factorial 5, then here in this case factorial 2 into factorial 3. After this I shall be getting on complete reduction. It will be, the result should come as like this, 6 into 5 into 4 into 3 factorial let us write it down in proper factorial notation what we had been using till now. So this is 3 factorial, so 3 into 2 into 3 factorial into, so 5 into 4 into 3 factorial, here it is 3 factorial into 2 into, I get here 5 into 4 into 3 factorial, then 2 into 3 factorial, these two gets cancelled, result is 2 here, then 3 factorial gets cancelled, again 2 here, these two got cancelled, then I get here 2. So after complete multiplication I should get the result as 2000, and this is the answer for this one. Then after, so here we did up to question number 5, means 5 questions we had already solved here. So we shall continue with the remaining videos. Thank you.